Hello teacher, my name is İsmail Ketenci. Now I will show you how this program works. We have two different classes. One of is the test class. It will call all methods in our main class. Not main class, I'm sorry, our methods class. So we will talk about what they do and what's their time complexity. Let's start it with adding breakpoint in third line. So I will debug as and run with debug. So let's start it. In here, we create a new object. After that, it will call the constructor of the list class. So let's see. Yes, we will call this constructor, and in here, lists is initialized as an empty array with default size. So our number of entries is 0, set to 0, and we will go back to a list test again, and we will call the add method for object of 10. So in add method we have ensure capacity method. So this method called to check if the array has enough space, but in here we don't need resizing, so it will false. It must be false. So after that, 10 is added at index 0 of our list, and the number of entries is incremented to 1 in here. So let's back to a list test again, and we want to add 20. We'll call add method again, and it is same as like 10 at 10. We will call the add method again, and we will call ensure capacity method again, and we don't need resizing, and 20 is added at index 1 right now, and our number of entries incremented to 2 in here, and add 30. It's same like the other ones. We'll call the add method again, and we'll call ensure capacity again, and we don't need to resize again, and 30 is added right now at index 2 of our list, and number of entries is incremented to 3 in here. So let's back to here. Now we will call toString method. Let's see. In here, string builder SB object is created and initialized with the character starting brackets to start the string representation of the list in here. After that, there's a for loop, so it iterates over each element in the list from index 0 to number of entries minus 1, and number of entries holds the current size of the list. So there is an append method. This if condition checks whether the how can I say, inside the loop, inside the loop, the ith element of the list is appended to the string builder object SB. This adds the actual list element like 10, 20, 30 to the growing string. Okay. After that, there's a if condition in here. It checks whether the current element is not the last element in the list. If it's not the last element, a comma and space are appended after the element to separate it from the next element in the list. Okay. And if it's the last element, no comma is appended, ensuring that the string representation of the list doesn't end with trailing comma. So first of all, our index 0 element is 10, so we add square brackets and 10 and comma space. After that we continue the loop. There is a 20, we add 20. After that comma in here. After that 30 and comma, and our number of entries is finished. 3 of them is writing right now, and we append the square brackets, closing square brackets, and return this object. So we can see here. Let's talk about the other add method. There is a given position and new entry. We want to add index 1 I'm sorry, 15. So we'll call the add method, and it shifts 20 and 30 right to make space at index 1, and 50 is inserted at index 1. Number of entries becomes 4, and we will back to the a list test again, and we will write like we will call this to string again, and we have 4 different entries. So one of is 10, one of is 15, one of is 20, one of is 30. So these loops work 4 times. First one, second one, third one, and fourth one. And this loop's finished, and we add square brackets, closing square brackets, and we will return the SB. And it must write like this. After that, we will call remove item, remove of 2. It will explain us the element 20 at index 2 is removed, 30 is shifted left to the fill in the gap, and our number of entries decreased to 3 in this method. We'll call, and there's a loop, so we remove the second item, second index. So our 20 is deleted right now, and we will call toString method, and our number of entries is 3 right now, and we'll call 3 times this loop, and this loop is finished, and there's a closing square brackets. After that we have output in console like this. Our 20 is deleted right now. After that we have getEntry method in here. The getEntry method retrieves the element at index 1 for this line, and it directly returns the element from the list array at the specified index. We can see here. After that it must be right like 15 in here, and we will call contains method. This method performs a linear search through the list to check if the element 20 exists. It returns true if the element is found. Otherwise, it returns false. So we deleted the 20 previous line. So now we don't have element name of 20. So it must be false. It must be false. It checks all elements. This loop checks all elements. So it cannot found because we don't have 20. So it returned the false. and it must write like this. And we call the replace method. This method replaces the element at index 1 with 25. The element at index 1 directly update without needing to shift any other elements. So after this replacement, list toString called in the next line. So we have 25 for index 1. We add it in here, and we will call toString method, and our how can I say, our entries, number of entries is 4 right now. It will be run 4 times, 2, 3, 4, and I'm sorry, we have 3. We replaced it, so our first item is 15, but now it's 25. It changed. So let's talk about the other line. This empty method checks if the number of entries is 0. It returns true if the list is empty, but our list is not empty, so it returns the false. After that, getLength method directly returns the value of the number of entries, which represents the number of elements in the list. We have 3 elements, so it must be 3. Now let's talk about the time complexity of these methods. Now let's talk about the time complexity of these methods. So first one is add method. Normally O1, but if the array is full, its resizing takes ON. It's copying the elements. ON. This one is amortized. This one is worst case. This one, the given position of add method. If adding in the middle or beginning, elements must shift right, so making it ON. Our time complexity is ON in here. Remove method. We'll talk about the remove method. In here, if removing from the middle or beginning, elements shift left, making it ON. In here, our time complexity is ON. GetEntry method is direct array access, so it's always O1. Contains method scans the list to find the element, so worst case is last item or not found. So our time complexity is ON. After that, we'll call the replace method. Replace method directly modifies an element at index. It's always O1. O1, our complexity. And isEmpty method, there is, so just checks if number of entries, so it's always O1. And we have getLength method. GetLength method returns number of entries, so it's always O1. Now we will talk about this one. The time complexity of this method is ON because when resizing the required, as it involves copying all elements to a new array, so it is ON. let's talk about the toString method. So the time complexity of toString, time complexity of toString is O n, because as it iterates over all the elements in the list to build the string representation. So it's O n. Our program is finished, and I explained all time complexities. Thanks for listening. See you next week.